Question 7, and we have to draw a circuit diagram to investigate the relationship between potential difference, current and resistance for a filament lamp. Okay, so straight away we know some of the components that are going to need to go in there. We're going to struggle if we don't have a filament lamp for a start, so let's get that in. We need to know the potential difference across this filament lamp and the current through the filament lamp. So we're going to need an ammeter and a voltmeter. We're remembering that the ammeter always goes in series with our bulb, so that needs to be in the same line. But a voltmeter always has to be in parallel with the bulb. Incidentally, sometimes you might see a bulb being drawn like this. That is also absolutely fine. I've used the cross symbol, but that is fine as well. Either would be acceptable. So we've got our bulb, we've got our ammeter to measure the current through it, we've got our voltmeter to measure the voltage across it. That's all well and good. The whole thing is not going to work unless we stick some sort of power supply in, so we could stick in a battery, something like that. That would work. That's a cell, of course. If we put several together, that would be a battery. Alternatively, if you wanted to, if the mood took you, you could put in a power supply like that. Doesn't really matter. But either way, you need some sort of power supply, and also you're going to need to have some way of varying how much current and voltage you're getting for this bulb. So the easiest way to do that probably is to stick in a variable resistor, preferably not drawn quite as terribly as that. That, believe it or not, should be a rectangle with an arrow through it. Never mind. So 1 mark for saying or showing the ammeter with the correct symbol in series with the lamp. Got it. 1 mark for saying the voltmeter is there. It's going to have the correct symbol, V in a circle, and it needs to be in parallel with the lamp. Lovely. And then a valid method of changing the potential difference. So that would work. There are other systems as well that you learn in A level, but we won't go into that. Something called a potential divider, which you might have seen potentially in DT, if you've studied electronics at any stage, but we won't worry too much about that. That will get you your 3 marks. We move on, and we've got 3 graphs to look at. We've got to state the name of the component, so no explanation needed, we're just stating. This is a nice straight line, so this is something that's ohmic, it's obeying Ohm's law, so you could say it's an ohmic resistor, you could say it's an ohmic wire, or you know what, you could actually just say resistor or wire. Any of those things would be correct. Nice straight line through the origin, shows that the potential difference is proportional to current, yada yada yada. That is going to be a resistor or wire. This one is your bulb or filament lamp. So this is steep at first, and then it gets less steep because the resistance is increasing over here, and that is because the wire is getting hotter. And then the final one here is going to be your diode. So we had resistor or wire, we had filament lamp or just lamp, and we have a diode here. You could call it a semiconducting diode if you want to be fancy. You don't have to though, it's basically just a diode. So once we've labelled that one, the last part of this is this question here. You had to explain how the current varies with the potential difference for this component, the diode. And you've got to refer to the resistance of the component in your answer. So let's have a look at that graph again. So we'll describe how current, the relationship basically between the current and the potential difference. So let's have a look. Over here, this part of the graph is pretty much flat. Pretty much no current going through for these voltages over here. That suggests to me that the resistance is very high. And also, I'm remembering from my revision that the resistance is very high for the diode until we get to a certain voltage. So no current going as the voltage increases. Then after a certain voltage, happens to be about 0.6 volts, the current rises. And it rises pretty sharply. There's a nice steep gradient there, which means the resistance is decreased. So 1 mark for saying no current over here as the voltage starts to increase, and then the current starts to rise over here. 2nd mark for saying it's going sharply because, or saying we've got a much steeper part of the graph here. And thirdly, it's because the resistance here has dropped off. It's associated with a decreasing resistance.